So here, now I'm going to describe the process of taking basically these JPEG images that are just images of my target with the laser line on it that are named with the angle and transforming them into a 3D point cloud. So I start with just a folder full of them, and I have my data generation.py script in here. And this is essentially the stock one. I adjusted the HSV mask here and also my LiDAR or my sensor calibration values as well. But other than that, it just writes out to a test results file when you run it, which I've been doing through Terminal since Pytron hasn't been working. And you can sort of see it just imports all the images and then continues to go through each one and cycle through each one. So once I've generated this text file, which when it's finished is just many values with the either zeros or the like 3D points that it has captured as with the HSV mask and what it is. I'm able to then, well, running the Python script will generate a plot, but I found it really laggy on my computer, so I prefer to use MATLAB. So using MATLAB, it will import the data from the test results file and sort it into X, Y, and Z based on the columns. And this is my script to concatenate the point clouds. So I do a little bit of filtering based on the location of the points. This isn't quite done yet. I need to refine this a lot because I seem to have a lot of extraneous points. But afterwards, I create a point cloud object in MATLAB, which allows me to transform it a lot more easily. So here I define my first point cloud, and then my second point cloud, which is imported from an angle that's 90 degrees offset. So I have cloud A and cloud B as my variable names. And then I define a matrix representation of a geometric transformation, which is here I transform it about the z-axis. The angle is pi over 2. And then I also translate it in the x, y, and z directions to get them to overlay more smoothly on top of each other. So I define the matrix here, and then I use the affine 3D command to turn it into a transformation object that I can use with the PC transform function, which basically transforms one of my clouds based on that geometric, the matrix that defined the transformation I wanted to perform. And so then I just use PC show, and I'm able to show both clouds. And as you can see here, it maps all the points, and they're overlaid roughly on top of each other. And you can sort of see, actually, because of all the noise, the different angles that I took. This one is only using 2. It's a lot of guess and check and trial and error to be able to overlay them properly, since I'm sort of manually adjusting the values, and it gets more tricky with more values. But that's the basic process of how to take the JPEG images and ultimately transform them into a complete point cloud.